Okay, hi. I'm Marion Fass. Most of you know that. And I'm really glad to have you here as part of the Lunchbox Series. What I'm going to talk about today is pandemic predictions, but I'm really not going to talk about predictions because I don't think I have quite that much arrogance to try to predict what's going on. But what I'd like to do is talk with you about what I really worry about emerging infectious diseases. I've been teaching about emerging epidemics here at Beloit College for about 20 years. And one of the things that I've done is try to think about it from the perspective not of the humans getting the disease, but of the germ. And so I think this cartoon from the far side that used to be on my door in Chamberlain Hall of Science sort of says it well. You can see this man talking with a lovely woman, sort of lovely, at a bar. And he says, "Oh, you're from France. Say, you have lovely eyes." And at the bottom, the germs are saying, "Hey, everybody, we're going to Paris." And it's really important because the germs are very excited to be going to Paris, and diseases spread in ways that we have very little control of. In a way, in thinking about epidemics of the future, we're haunted by the past. We're haunted by the 1918 flu and by the more recent HIV epidemic. Influenza killed 50 million to 100 million people in 1918. HIV/AIDS has infected about 70 million people since 1981. 35 million of those have died. HIV continues to take its toll around the world in terms of death, even though we've done tons of research, we have lots of education, we have lots of medical advances. Both HIV and influenza are caused by viruses, and we'll be talking more about viruses, but the high rate of mutation in viruses enables them to adapt to new opportunities and new hosts. And these pandemics also warn us of the challenges we face in terms of human behavior, in terms of climate and urbanization. And so we'll see how some of that plays out. There are so many new diseases. We keep hearing about them in the news all the time. And the success of new epidemics and outbreaks are going to be dependent upon four particular factors: ecology, evolution, human behavior, including access to care and equity, and then opportunity and chance. And the World Health Organization, the Institute of Medicine have come together with a One Health initiative advocating integrating ecosystem health, human health, and animal health. Now, I know you want to see this diagram of what's out there in more depth. If you look at the colors here, the yellow dots are arthropod-borne illnesses like dengue, hemorrhagic fever, in Cuba and creeping up into Florida. The red dots are rodent-borne diseases like sin nombre virus. We're not going to talk about those very much. And the purple ones are diseases that come from or that are spread by other kinds of organisms, including bats. And so we'll talk a little bit about bats. The most recent outbreak was the SARS epidemic, or SARS outbreak in 2002. It was big enough to stop Major League Baseball. I don't think I worry about SARS in terms of its recurrence here and its impact, but I worry about the lessons that we've learned from SARS. SARS was a viral disease, severe acute respiratory syndrome. It was spread by direct human-to-human contact, started in about 2002, but there may have been cases before that in China. SARS traveled by airplane very rapidly around the world. And what you see at the bottom is a poster that was put out by the government of Hong Kong. So SARS started in China. It was amplified in a hotel and a hospital in Hong Kong. It flew to Toronto. On this map, you can see the countries that are colored in red are ones where there was direct local person-to-person transmission. The countries in pink are places where there were a few cases, but they weren't spread directly from person to person. The dots show the numbers of cases. Globally, there were over 8,000 people infected and 774 died. This was not a pandemic. It was actually evidence of a really good response by the World Health Organization in in a country with excellent infrastructure, or countries with excellent infrastructure. And so quarantine and communication really worked to stop the spread of the disease and its toll in terms of mortality. But what we also learned from SARS was that some individuals are super spreaders, that they give off massive amounts of virus in comparison to others, and that if you've got a super spreader in a hotel with bad ventilation or with lots of places to put your hands up and viruses that transmit easily, you've got a big outbreak. And so SARS spread rapidly right away and had a high mortality rate, but was really brought under control early. But now we're left with this question of where did SARS come from and will it come back again? SARS is a zoonosis, a disease of animals, like many of those diseases that we saw in the map. And one of the biggest concerns right now is what diseases are going to spill over, to cross over from different animals to humans, and how will they get there? When SARS first broke out, it was identified in civet cats, those nice little animals there, that were sold in marketplaces in China, both for pets and for food. But further investigation found that it wasn't the civets that harbored the viruses, but probably horseshoe bats, the ones down there. And horseshoe bats are reservoir hosts. They probably don't get sick from the disease, but they spread it in their saliva, in their feces, in their urine, and they spread it to different kinds of domesticated animals. Future outbreaks may come from bats. And bats are really great hosts for disease if you think about it. They may be infected with many kinds of viruses. They may not show them. Bats are mammals. They have physiology very similar to ours. And they have viruses that are very similar to ours. So that idea of viruses spreading from bats to humans is not real far-fetched. Bats travel widely, just like the people who got on the airplane in Hong Kong with SARS and traveled to Toronto. Bats don't travel quite that far, but they spread things easily. And if you think about it, bats live in slums. They live in large colonies of 100,000 individuals to 1 million individuals. They don't benefit from the Centers for Disease Control. If somebody wanted them to quarantine, they wouldn't understand what it was. They don't have toilets and they don't worry about fresh water. And so the opportunity for them to spread disease to other bats, to other colonies of bats, and to other animals is really tremendous. And with changes in land use and urbanization, bats are coming into more contact with people. So this is ecology and this is opportunity. There are lots of different viruses that recently have been identified in bats, including MERS, the Middle Eastern respiratory virus, a coronavirus, which is in Saudi Arabia and the Middle East. Ebola virus antibodies, not Ebola, but enough of a hint of Ebola that we think that maybe Ebola is spread by bats. Another SARS, pox virus, rabies, of course, hepatitis, and bat influenza. And I want you to think about bat influenza because bat influenza is really scary. Influenza is scary. Influenza caused all those deaths in 1918. It's a virus with its genetic material in RNA, but its genetic material is in 8 segments, so that while most viruses and most organisms we think of mutate slowly in little steps, viruses mutate in big chunks. They reassort their genetic material from different kinds of organisms. They even mix the genetic chunks from viruses that are infecting different species. So imagine this relatively scary scenario that there's a pig, and the pig is infected by pig flu, and he's sneezing a lot, but he finds an apple, and the apple has been covered in bat saliva, nice fruit bat. And so the pig eats the apple and becomes infected with bat flu, and the bat flu and the pig flu mix up in the pig's gut, and the pig sneezes on a human, and perhaps that human is infected with a new strain of virus. Now, there are many strains of viruses mutating, but the potential for this new reassortment, I think, is what's really scaring epidemiologists as they try to predict what will be the next influenza outbreak. We're not any better at treating influenza than we were in 1918. Even though we understand it better, we're not any better prepared. So I want you to think about diseases differently in terms of, we used to think about diseases as an individual gets a germ and they get sick, but we're going to throw that out and think about this ecologically and epidemiologically, that we can think about characteristics of the agent of disease and how it's spread, how easily is it spread from person to person, how quickly does it kill, are there opportunities to infect lots of people? We can think about characteristics of the reservoir of disease, that host. Is it an illness that affects just humans or other species? We really worry about those diseases that affect both humans and other species. It's a lot harder to control them. Is the host literate, educated? Bats aren't. How do they live in terms of density and the ability to spread disease? What's their immune system like? And finally, we can think about the environment. What are those kinds of characteristics that make it easier for diseases to spread? Is it climate? Is it urbanization? Proximity to other species? All kinds of factors. When you think about the environment, I want you to think about mosquitoes, because there are a lot more mosquito species out there that live in different habitats than we generally consider. It's one of those questions of ecology. And many of the pathogens that we're worried about are ones that are spread by vectors of disease, like mosquitoes that go from host to host. In this picture, you can see the Anopheles mosquito that spreads malaria. The Aedes albopictus, the Asian tiger mosquitoes, they both have red bellies because these are female mosquitoes that have fed. West Nile virus shows us an example of disease that's spread by an opportunity. West Nile virus arrived from Israel in 1999. It arrived in New York City. It probably traveled in a goose. But the Aedes albopictus mosquitoes bit the goose, bit another bird, created a cycle of infection, and then began to bite humans. And if you look at the map, you can see that in 2001, they're red dots. The West Nile virus was really restricted to the East Coast. By 2002, it had spread all the way to the Rockies, and by 2004, it had spread across the United States. West Nile virus is now endemic in the United States. It's everywhere. It doesn't kill people most of the time. It's not an epidemic. It's just kind of settled in. But there are mosquito diseases out there that I think we can worry about or should worry about more. First is thinking about Aedes aegypti and Aedes albopictus, these mosquitoes that really have adapted, evolved to live in our urban environments. They live in old tires, they live in puddles created by plastic bags, they breed in these environments. So these are really hardy mosquitoes. And they're vectors of a disease called dengue, which is also known as breakbone fever. Dengue has recently reappeared in the United States, in Texas, and in Florida and New York. Around the world, more than 2.5 billion people are at risk, and 390 million were infected last year. Here's a disease you probably haven't heard of. And dengue is a disease of urbanization and climate change and changing ecologies. I want to share with you an article that was written by a colleague of mine in graduate school who got dengue in Thailand, and it's just so powerful. He said, I got more and more out of it. I was close to hallucinating. I couldn't get out of bed. Half my hair fell out. I started seeping blood through my hands and feet, just leaking right through the skin. You could see it on the sheets. I was purple from my mid-bicep to my fingertips and my mid-thigh to my toes. My wife said she'd never seen anything so bizarre. Its common name is breakbone fever. The pain is unbelievable. Now, the first time you get dengue, you may not know it. Dengue is caused by the dengue virus, but there are 4 subtypes, but they don't have flags on them. So you may get infected by dengue 1, and if you get infected by dengue 2, you are likely to get very ill. If you get infected by dengue 1 again, your immune system will fight it off. These strains used to be geographically isolated, but they're no longer isolated. They've moved around the world. So who's most at fact? Poor children, poor communities, and people who've been infected more than once are likely to get dengue hemorrhagic fever, dengue shock syndrome, a really horrible set of illnesses. And here's a global map of where dengue has been, countries where dengue is at risk, but we're going to skip that and go on to bacterial infections, because the final category of things to worry about, I think, are antibiotic-resistant infections. We use antibiotics to treat bacterial infections in humans. We use them to treat animals that we raise for food in large numbers. About 50% of the antibiotic prescriptions that people in the United States get aren't needed. And there's some real questions about whether antibiotics to promote growth in farm animals are needed either. But what they do is create the conditions for the evolution of drug-resistant pathogens. And bacteria have special strategies that help them speed up their evolution. They can share chunks of DNA coding for resistance to antibiotics to other species and to different bacteria. So this is creating what may be called the post-antibiotic era. The CDC is worried about this. They talk about potentially catastrophic consequences of inaction. The diseases that are on their most worried about list are gonorrhea, which is rapidly becoming resistant to the antibiotics we have, and 2 hospital-acquired infections, C. difficile and carbamazepine-resistant enterobacteriae. These cause a huge number of illnesses and diseases or deaths within hospitals. Tuberculosis may also, or is becoming drug resistant. We don't see that very much in the United States. It's more likely in Russia and South Africa and Mexico and Peru, but it's only a plane ride away. So the CDC is worrying about a post-antibiotic era, and it's not because we may directly experience the drug-resistant strains, but we will experience the loss of antibiotic power. We've become used to the idea of controlling bacterial infections, and without these antibiotics, our lives may change profoundly. A visit to the dentist will become much more worrisome. Childbirth will be more of a risk of infection. We may worry about hip replacements and kidney dialysis, any time where bacteria can potentially be introduced into the body. And we'll worry a lot more when our kids get strep throats and ear infections, because prior to the use of antibiotics, these were really serious, potentially life-threatening or disabling infections. So they're flashing time things at me, so I'm going to conclude with 3 concluding slides. One is to remember that these diseases are out there, and as we think about the environment that puts us at risk, we need to think about the social environment and the social determinants of health, that these are global diseases. They don't stay in one country. And where we live, work, and play, and where people around the world live, work, and play really affects vulnerability, poverty, lack of education, hunger, and access to clean water really affect who gets diseases and how they spread. War really disrupts the infrastructure that we've come to depend upon to control disease. And right now there's been an outbreak of polio in Syria. With the continued war and civil war there, kids aren't getting their vaccinations, and so there's been an outbreak in small children of polio, and WHO has gone in to distribute vaccines and try to control that. There is some room for optimism. There have been improvements in surveillance and communication spurred on by the appearance of HIV and then by all these other outbreaks of disease. The UN Millennium Development Goals have really taken action at a global level, spurred action to reduce poverty and improve infrastructure and focus on disease control. As I mentioned at the beginning, we're seeing this collaboration among people concerned with animal health and human health and ecosystem health, recognizing that these are all based on ecology and evolution, that this is an ecological issue. And funders like the Gates Foundation have really focused on health as a priority and made a tremendous difference. So I want to leave you with some advice. Wash your hands and wash your fruit. When you can, stay away from sneezing pigs and from bats. Both of them are risky. Wear mosquito repellent. As we get ready to move to Florida, I really worry about dengue, which is spreading up through South Florida. Get your flu shot, even if you don't think you need it, because you might. And don't take pills that you don't need. Remember about those antibiotics. If you have them, finish them. Try to avoid the hospital. It's a very dangerous place. And support efforts to control diseases in other countries. Diseases don't respect borders. It's also a very nice thing to do. So I want to thank you for being here and listening to me, and I think we have time for questions. Yes, Nancy.
What are the characteristics of a super spreader?
The characteristics of a super spreader, you can't tell if you're one, okay? It seems to be biologically that some people just shed more virus, put out more virus in their bodily fluids. And I don't know. It's one of those things, so much of this, it's that idea of how can we predict, and so much of these are things that we don't yet understand or aren't under control. We can also think of a super spreader as somebody who's in the position to spread a lot of disease. And so if you think about the movie and the band played on about the beginning of the AIDS epidemic, some of those airline stewards who traveled the world were super spreaders because they had lots of partners in many places.
Has anybody done any studies on the bats around here locally and what kinds of viruses or bacteria they may be harboring?
I think that's a really interesting question, and as far as I can tell, scientists are just beginning to have the guts to go out and study colonies of bats, because the challenges of going in and grabbing them and getting their blood and trying not to be bitten is challenging. So I don't think we know what the bats around here are carrying. And not many are carrying rabies. We seem to be not seeing a lot of rabies being transmitted. I'm trying to encourage people to go on and become bat biologists. They're really quite beautiful. But I really love that picture. But you've got to get out there and get them. Oh, good. Well, what you want to do is make sure to wash your hands and everything really well and wear gloves, right? Yeah.
In terms of the multi-drug-resistant bacteria, I kind of get the sense, I've recently been to the doctor a couple times and have been prescribed antibiotics, and never has a doctor told me, make sure to take all of your pills. And so I'm wondering, I think it's our responsibility to be aware of this, but as well, is there anything, do you think that there's really any movement from the medical community with regards to concern for overuse of antibiotics, overprescription of them?
Oh, yes, of course there are efforts within the medical community, but there is also all of these issues in terms of how we communicate with our doctors and what we understand from our doctors. About 10 years ago, Nancy Kresko and I did a study where we asked patients and doctors about how they responded when they thought they were sick. And most of the moms said, well, I can tell when my kid needs an antibiotic. And I'll call the doctor and say, my kid has green snot and I need an antibiotic. And the doctor knows me, and he or she will give me the pills. And the doctors also talked about feeling compelled by patients to give them the pills because the patients were demanding. And so I think that we've set up a situation where we expect to get something when we go to the doctors, and therefore the doctors feel that they will let us down and we'll go somewhere else if we don't get a prescription. So I think that it's going to take a lot of very concerted education. And certainly the CDC is trying that. Yeah.
There seems to be a trend, at least I read about it in this country, with parents who are not getting kids vaccinated, whether it's something they read or a financial issue. Are we reaching a tipping point where herd immunity is starting to get threatened by this, or is this still small enough pockets of people that it's not so much an issue?
I think that there are outbreaks regularly in communities where people where people aren't getting vaccinated. Or where a disease has entered the community in large numbers. And this is really dangerous. You know, we're at the point now that none of us have seen measles or chicken pox or polio, and so parents think, I don't need to participate in this. There's a slight risk for my kids, so I'll opt out. And I think that we may see it in the future in more of these outbreaks. And then hopefully health departments will respond by swooping in on that. It's really a worry. Oh.
So as these viruses begin to mutate, are there... I thought there's a bat flying down.
There's a bat up there. No.
There's a bird. So, I mean, maybe it's just kind of I have limited knowledge of how vaccines and antibiotics work. But as these viruses begin to evolve to become resistant to not only antibiotics, is there a chance that they could become resistant to some of the vaccines we've developed as well?
Okay, so separate out viruses and bacteria, right? Yeah. Because bacteria respond to antibiotics, but viruses don't. But yes. I think that most of our vaccines are general enough that they seem to be, I haven't seen much of a questioning of whether the vaccines are going to wear out. Some of the issues, certainly with influenza, is that it reassorts so much every year that the vaccine that you got last year may not be appropriate for the flu strain next year. And so that's why this effort is to make sure that people get a new flu vaccine every year, because flu just keeps reassorting and reassorting. You have to realize that these bacteria and viruses are evolving on their own without the pressure of drugs or situations, but that when there's an opportunity for drug-resistant bacteria to thrive and spread, they will. Yes?
Where does the anti-flu shot, whole thing that I'm getting from everyone, I saw the flu shot at Commons and everyone came up to me and said, don't take the flu shot, it's bad for you. Where is that coming from?
I don't know. It was my class that was promoting it. I think that, we worry about a fear of needles. It hurts when you get a flu shot. The flu shots seem to have a very low rate of side effects. And, for the most part, many of the strains of flu seem to affect older people, people over 50, not people under 25. However, the worst strains of flu that we've seen, the 2009 one that you may remember, and the 1918 one, which none of us remember, affected people under 25 much more severely. And so I think it's the feeling that college students aren't vulnerable to any kinds of disease. So stay away from this. It's a waste of time. We talked about that a lot in class. I think flu shots are really important. Yes?
I'd like to remind college students that although they're unlikely to die of flu, they are likely to give it to their grandmother or their nephew who's 2 years old, and they are at risk. So the idea of herd immunity is very important. It's a public service to get your flu shot.
Thank you. Yes.
Bringing it back to the antibiotic resistance, are pharmaceutical companies taking any other approaches in treating disease or treating bacteria infections if antibiotics are going to not be able to do that in the near future?
I think there are efforts to develop new antibiotics, and there are also efforts to develop antibiotics using completely different targets. And if you're interested in this, there's a really wonderful TED Talk by Bonnie Bassler looking at communication between bacteria and trying to focus on that idea of if bacteria don't start infecting us or causing disease until there's a herd, a community of them, can we work with their signaling? So figuring out novel ways of disabling bacterial disease mechanisms. And so, that will move us into a whole different realm of medicines. And so, yes, the pharmaceutical companies are working on it, but the challenge is that it's a lot less profitable for a pharmaceutical company to come up with an antibiotic than a new drug for baldness. There's a much bigger market for baldness drugs, and so they go where the market is. So that's a real challenge that we face. Yes, Larry.
Thank you. Is there anything in Obamacare that's likely to have an impact on the spread of infectious diseases?
There are lots of things in Obamacare that I think will have some impact. One may be efforts to treat people in the community instead of in hospitals, to continue primary care for people with chronic diseases in the community rather than in hospitals. There's a lot of surveillance in place looking at hospitals on their rates of infections, and so the ability to direct people to low infection hospitals, which will then put a lot of pressure on high infection hospitals to clean up their act. You can go online right now and compare hospitals, but there's not a lot of data on the local hospitals out there yet. I tried that last night. So I think that there is, but one of the things we learned in the city of Beloit about 7 years ago is that when the health department is really effective, it's invisible and people don't value it. And so it's really important at a national level to continue investment in public health and community health, at a national level, at a local level, at a community level, because we forget how dependent we are on these infrastructures. And so you see things like this polio outbreak in Syria or challenges in other communities where infrastructure has fallen down, disease outbreaks come back. Is there another one? Oh, it's Amelia again, yes.
So you were just talking about hospitals having different levels of infection rates.
Mm-hmm.
And so what are some strategies hospitals are using to lower their rates of infections that occur within the hospital setting? Do you know of any?
I'm going to pass on that because it's going to take me beyond my comfortable level of expertise.
Okay.
Okay? Nancy needs this.
I see your pig up there,
yes.
And I thought the example was interesting because, you weren't going to make predictions, but in some ways, symbolically you did, because you had the pig eating an apple, and it's a female pig named Eve, I think.
Oh, is that what this is? Okay.
Does this mean that, we're all going to fall apart?
I think that there are animals out there that are more likely to spread disease to humans than other ones, and it seems that pigs are some of those. Chickens, pigs, and bats seem to be the ones that we're most concerned about, but certainly there are questions with the beginning of HIV, where it originated, how it crossed over from primates to humans. And the other thing to remember, too, is that human diseases cross over to primates. And right now there are terrible outbreaks of Ebola and I guess Ebola mostly in the primates in sub-Saharan Africa, and a real challenge, whether that came from bats or came from humans, it's not clear, but really challenging rates of infection, Ebola and simian immunodeficiency virus. So we're seeing a lot of back and forth. Yes, Kathy.
So what's the role of school teachers and the schools in promoting scientific literacy to help stop epidemics?
Oh, I'm so glad you asked that. Because, I think there are opportunities to begin with hand washing. A couple of years ago, my walking partner was a first grade teacher, and we spent a lot of time talking about infectious diseases as we walked, and all of her first graders washed their hands all the time. They used Purell gel. They washed their desks, and nobody had flu that year, and she was really excited. So starting to talk about food sanitation, washing your hands, those basic things to stop the spread of disease, talking about how one interacts with doctors and the healthcare system, and basic scientific literacy, understanding when is the right time to take pills and when isn't. That I think all of this begins with elementary school teachers, and there are lots of ways to think about activities in the classroom that will promote scientific literacy and health literacy, and health literacy is a really important concept. Yeah, Mark.
Going off of that, what is your take on antibacterial soap? We've heard different opinions on that. When we're washing our hands, how should we be doing it?
I think that antibiotic soaps are kind of a waste. I think soaps are really important, but there's nothing to really say that those antibiotic soaps are that much better. And there are some people who really believe that they're contributing to antibiotic-resistant infections. But it's really hard to find soap that isn't antibiotic unless you get Ivory or you shop at the farmer's market. All right. Thank you all. This was fun.